So this is power all mixed up. This is the Jambalaya section of the worksheet. Okay, and so all we've done, the only formulas you haven't already written down are ones you already have. You can also add that velocity is distance over time if you would like to. I don't know that there are so many that do that, right? And then if I hit the right arrow, here are the things we can know. Right? And I think do we have all those down? Except we don't have acceleration, right? So let's add that one. Acceleration. This is meters per second. And it's acceleration. Oh, meters per second squared, sorry. And then this is acceleration. And then we also need, I guess we need another formula here. We can also say F equals ma, right? So if you had a situation where you were accelerating an object that was what the force was doing, you would use this. I don't know that we're going to run into so many because there's a more elegant way to do that. But I think we've got all of those things. You might want to add in your cheat sheet, right? You might want to add the conversion. 1 horsepower is 745.7 watts, right? And then a kilowatt is 1,000 watts. But this is it. It's all you need, I think. I don't know. We might find something else. Yeah, it's crazy, huh? It's a Jambalaya! Sorry, Jambalaya. Right? Okay, so sample question number one. Sample question number one. A 1.2 horsepower winch can lift a 2,350 kilogram. Shut up. Could I have your attention, please? Can lift a 2,350 kilogram Land Rover into a 14.5 meters up into a tree at what time? How many people have seen this movie? This is one of the best movies. No. No, yet? No. Land Rover, he can't, his Land Rover stalls in the river. He can't restart it because it's got new piston rings. So he takes the winch out and and there's nothing there, but he looks up and there's a branch above in the tree. So he throws it up in the tree. It hooks on the tree, and then he turns the winch on, meaning to turn it off before it goes all the way up into the tree, but after it goes out of the river, right? But he's detained by some other thing, comes back, and his Land Rover's hanging out of the tree by the winch. Have not seen that? What is it? The Gods Must Be Crazy. How many people have seen this movie? 2 people. This is one of the best movies. It's up there with like Princess Bride, as like all-time great movies. The Gods Must Be Crazy. I've just planned part of your weekend. All right, now, this problem. Who's got something that can go at some spot on this thing? Yes, Sam's got some. What is it?
Oh, the
2,350 is what? That is the mass. You betcha. Yeah, we got to figure out the wattage, don't we, right? So the wattage is going to be 1.2 times 745. That's why you guys are so smart, because you know that you've got to figure that out, right? What is it?
894.84.
84 watts. There we go. And then what else? What else do we know? Sam knows something else. What is it? Yeah. Yeah? Gentlemen, this is the part where I want your attention. Okay, and then the other thing we need to know is, what is it that we're doing? Are we lifting, dragging, accelerating? We are lifting. There we go. Right? This is for accelerating. Hopefully the Land Rover is not accelerating. So, seems to me like if we know we're lifting, can't we find out the force? Yeah? So step one, we can find the force, which is going to be the weight of this thing. not the mass, but the weight. So 2,350 times 9.8 is, so this is, right?
Add more things.
All right, turn them in. Right? And then what are we trying to find? We're trying to find time, right? And now we need something that relates the things we have to time. And of course, you know, gee, I bet it's this one, right? Don't you think? Yeah? Okay. So time is going to be the work we need to do divided by the, power. This is not, I put this in the wrong place, didn't I? I put watts for work. This is, by the way, a real common thing that students do. You actually want to put this down here, right? Don't we?
Yeah.
894.84 watts. W is the unit, not what it is. There we go. Now we're in better shape. So erase it from there, put it there, and now, do we have work yet? No, we don't even have work yet. What can we figure out, though? Yeah, we can figure out work. It's like, yeah, there we go. Yeah, we can figure out the work. We can go force times distance. So I can go this times this. So that answer times 14.5. And I get just a buttload of work, right? 333,935 joules. Now what can we do? I thought we were done. It's 3 steps. It's crazy. What can we do now? Yeah, work divided by power will give us time, right? So this is going to be 333,935 divided by 894. So this is joules divided by watts is going to be seconds.
How'd you get that
Force
force?
was we did this times 9.8. We did this guy, right? So that was number 1, right? Number 2 was this guy, right? Number 3 is this guy, 3 steps, right? So this guy divided by 894.84 is 373 seconds. Yeah? Do you feel like you've accomplished something? Yeah, it's 3 whole steps. It's not for the timid. Sample 1. Do we need sample 2? Do we want sample 2? Do you guys want to try it? Let's have you guys try it. That one was just dragging. We can drag. Now watch. I'm going to erase. I'm going to reset our thing that we know, and we'll together decide what it is we know. So I'm just going to erase stuff. You don't have to erase 9.8, but I'm going to erase it. Oh. Why isn't that erased? Oh, I used a permanent marker. Yeah, I did. Yeah, I really did. I did, you know, and the funny thing is the first year this school was open, I accidentally left a permanent marker on the little tray because I'd never seen a whiteboard in my life, you know, and I filled the board with permanent marker. I just was all over the board. I drew the biggest picture and everything like that. I went to erase and it was like, I'll show you how to erase it though. It's kind of funny. Do you guys know how to erase that? I can erase it with this pen. I just go, you know. The solvent in this pen will take the marker right off the board. Okay, so what are we trying to find? Probably. Try to find the power. That's what we care about, right? Right? 560 goes where? That's the mass. Right? 3.2 meters. That's a distance, right? And 1.5 seconds is time. Yeah, it seems like you figure out the force first, right? Because we are lifting, so it's going to be the same guy first, right?
Yeah.
Then if you know the force and the distance, can't you find the work?
Yes.
Yeah. And then
You can also skip just the power.
if you know